as our spring seminar for the UCLA Water Resources Group. The UCLA Water Resources Group is the group within the Institute of the Environment that, as its name suggests, really tries to bring together faculty, students, and other researchers at UCLA to converge on water topics, particularly interdisciplinary water research, as well as to engage with the public and really do actionable research and serve as a resource as well to the broader community and be responsive to community needs. I'm not going to say much more because we have a full lineup today, but I do want to also thank our sponsors, co-promoters, I should say, from across UCLA and our partners, namely the UCLA Luskin Center for Innovation, the UCLA Samueli School of Engineering, Geosyntec Consultants, and the UC Agricultural and Natural Resources Extension. With that, our main topic today is really the intersection of wildfire and water quality, which has been a long-standing topic of interest in the research and policy community. But we're also taking a broader look at how climate is impacting both wildfire and water quality, as well as particular impacts on sort of new or newly emphasized forms of stormwater capture, green infrastructure in the form of biofilters, which are a type of nature-based solution. To lead us further into sort of the intersectionality of these topics, I'm going to turn the floor over to Dr. Faith Kearns, who is the UC Water Institute Academic Coordinator. She coordinates research and outreach programs for the Institute. Her research interests really lie at the intersection of science communication, community engagement, relationship building, particularly as these topics relate to the environment and water resources. Faith has also managed a wildfire research and outreach center at UC Berkeley. And I also want to give a plug for her book, Getting to the Heart of Science Communication, that just came out, well, now in the last 2 years. But I thought there was really no one better than Faith to kick off this webinar with some opening remarks on these topics. So Faith, I'll turn the floor over to you.
Awesome. Thanks so much, Greg. So hi, everyone. I'm really excited to be here, and thank you, Greg, for the introduction. So as Greg said, I'm Faith Kearns. I work with the California Institute for Water Resources, which is located in the UC Division of Ag and Natural Resources, which for folks who aren't familiar is the cooperative extension branch of the UC system. So, I started working in this very community engaged part of the university on wildfire issues about 18 years ago. And I think while wildfire, has always been a challenging issue to work on, particularly as it relates to communities, right? I think many people would agree that the Tubbs fire, which many people will recall, happened in and around Santa Rosa in about 2017, really signaled a lot of different kinds of changes when it comes to wildfire in communities, including being the first time that it was really well documented that wildfire have this pretty direct impact on water infrastructure, on a community water system. That fire ended up, melting some city infrastructure and leading to some contamination issues. And, this pattern has been repeated in the Camp Fire, the Woolsey Fire, the CZU Lightning Complex fires. And that's just to sort of name the ones that have happened in the last few years that we really have such direct evidence of. And so, this emerging phenomenon of wildfire directly impacting water infrastructure is a huge challenge, and one that I think we are really only beginning to wrap our arms around, in part because it has, both this very sort of direct physical material aspect to it, which I'm sure we'll hear more about today, but also because the management and decision-making landscape is really fragmented. As a report that came from a workshop that Greg and I co-organized along with some other folks, documents these issues really well. And we can put a link in the chat to that report in case it's of interest to folks here today. So, as Greg mentioned, with a changing climate, which we all know is at the very least a threat multiplier, I think we're likely to see even more of these water and wildfire nexus issues. And there really is no doubt at this point that water and wildfire are very intertwined issues. So even, this year, just for example, with all the precipitation that we've had, it will be really interesting to see what happens as, my sense is probably that we've decreased fire risk in some places like high Sierra forests, while potentially also increasing risk in places like grasslands that likely will see an explosion of vegetation this spring that will probably be pretty dry in the fall, and places like the Mojave Desert that just didn't get as much precipitation as the rest of the state's winter. And, that leads me into today's topic. It's really exciting to see researchers who are working directly on some of these really thorny issues, as well as being willing to talk about them in an open public forum. As many people know, we've really gone through a transition over the last decade or two, and from thinking about stormwater as a nuisance to thinking about how to utilize it better for drought-related water security purposes and other things. And so I think we also need to be thinking pretty clearly about potential challenges to that supply, including wildfires. There's been some research by fantastic UC experts, including Mike Mendez at UC Irvine. His work has really shown that, disaster impacts are not borne equally. And even when it comes to things like boil notices for water contamination after a wildfire, they're often not reaching the people that they need to, including with basic things like having those available in multiple languages. So, excuse me, these are really high stakes issues. And I think it's really important for the research community to be involved in figuring out ways forward and to communicate that work transparently and in ways that are useful to both communities and decision makers. So I'm really looking forward to hearing more about the work that the C-Lab folks are doing to proactively get ahead of these issues where we can. And so with that bit of stage setting, I'll just hand things back over to Greg to introduce today's speakers.
Thanks, Faith. Thanks for that introduction and really setting the stage for our feature presentation, as it were, which will come from be co-led by Sanjay Mohanty and Onja Davidson Raoelison. Dr. Mohanty is an assistant professor of environmental engineering at UCLA. He also leads the Subsurface Engineering and Analysis Laboratory, or C-Lab, and really applies his research to develop innovative engineering solutions to remediate contaminated soils or treat polluted runoff for the protection of drinking water resources in a changing climate. Onja is a PhD candidate in environmental engineering and works within the lab, and her doctoral research focuses on mitigating the negative impacts of wildfires on surface water quality using green infrastructure. So you'll be hearing a lot more about that research right now, and I want to turn the floor over to Dr. Mohanty to lead us in.
Thank you. Thank you for the Water Research Institutes or Water Institute for organizing these sessions and giving this chance to share this research as well as communicate with both industry as well as other stakeholders. Climate is not a simple research or simple problem that can be solved by any single discipline. So that's why it's very important for us to communicate and collaborate as much as possible so that we can create a solution that is more lasting and more effective. So with that, I wanted to go to the next slide, please. And these are the 4 questions we'll discuss today. So I first present about why wildfire is an issue for California, particularly managing the water resource, something that we don't link together more often. And then next 2 questions is how we can design these green infrastructures to mitigate this negative impact of climate change, impact of wildfire. So this will be discussed by my PhD students. So Onja Raoelison is a senior PhD student. She has done all this work, so she is more familiar with this work than I am. And the next is going to give a demonstration or example of one type of design that really effectively removes some of the pollutant that we expect to increase during wildfire. At the end, I'll make some implications and a research need that hopefully will further the discussion on this topic. Next slide, please. So again, the first thing I want to mention is that climate change is increasing the frequency and intensity of wildfire. So if you think of climate change, we relate to many different things. It's partly because global warming is increasing the driving this wildfire because of dried vegetation, lower water quantity. And here is the pictures that shows that based on how much global warming, that intensity or the frequency of the more intense wildfire is going to increase. Just the 4 graphs just to show that increase in just 1.8 degree is going to increase the wildfire by 3 times. If it is increased by just one moderate 1.1 degrees Celsius, that's already 50% extra in catastrophic wildfire events. So what we have seen over years, that's going to increase a lot. Next slide, please. So this is just to one example from our work in the UCLA, just to show that how that this effect is actually it's the feedback process. Here one example just to show that wetlands in California are going to, many of the wetland is going to receive this wildfire affected runoff. That means it may have a lot of ash, a lot of black carbons, other stuff that will be deposited in this wetland, and that will change the cycle that wetland does. For instance, wetland, many of you probably know, wetland captures or at least have like 1/4 of global carbon. That's basically trapped inside these wetland sediments. So it can be a sink or source of methane gas based on what was being done here. So what we saw over here is that if you increase the deposition of wildfire residue, it's going to increase methane emission by a factor of 50% or more based on how much wildfire residue is deposited. This is just a lab study just to show that this increased methane emission can potentially increase more fire, and that will lead to even more these disruptions. Next slide, please. And so this is just to show that this is just one pathway that wildfire would increase carbon emission, that will potentially increase greenhouse gas, and that lead to climate change, and climate change will lead to more wildfire. This is just one link over here. There are many other links that you can see over here. So that's why it's very important to address climate change, not just one way, but many different angles to it. Next slide. This is why this is just a slide just to show that how much different goals, sustainable goals are affected by wildfire. And whenever we think of wildfire, most of the time we relate to poor air quality, because that's what we breathe in during the wildfire. A lot of times, what we don't see is the long-term effect of wildfire, like health. Health is something that if we inhale this wildfire contaminated air or contaminated water, that over time is going to develop. But how do we know that whether this is going to be affecting us or our communities? There are things that we could do beforehand, something like monitoring. Air quality changes very rapidly, so it's very difficult to predict that, at least in long term. Whereas water quality is going to last for a long time. So what we did over here is trying to understand the link between wildfire and water quality. Next slide, please. So this is just an example to show that this is Lake Tahoe in California. That's where the fire occurs this year or last years. And you can see that many of those fires are right near the edge of the lake. So every time this fire burn out all these those dry woods, next time it rained, like now recently last 2 months we have got a lot of rain, so that many of these reservoir is going to fill with water, and that water may contain this residue from wildfire affected area. Next slide, please. And how do we know that this water is going to be polluted or less polluted? No, there is no study. At least we didn't find that what kind of monitoring approach we should adopt. we are surprised to see that there very little monitoring is done over a long period of time to understand this effect. So what Onja did here is that she collected the global data and tried to understand based on different reports to what extent this contamination may occur and when it occurs. Just one example to show that here, this is the heavy metal concentrations ratio between post-fire and pre-fire. So the ratio is more than 1 log scale. That's 10 times increase in concentration of heavy metals because of fire. So what we see in the x-axis is the time when you take samples. So if you take sample less than 6 months ago or 6 months after fire, you may or may not see that difference in a change in concentrations. But if you take that sample between 6 months to 1 year, you can see that change in increase in concentrations to in log scale, it is around 2. That means 100 times increase in concentration of heavy metals. So this just shows that many times you may not see that impact right away, but you can see the impact a lot later. This is just one case. For other pollutant, the trend is very different. Some of the other pollutant, you see the impact rapidly within just after wildfire, not long time after that. So it's very important to be strategic about looking for these metals or pollutant concentrations. Next slide, please. And this is just to reiterate the fact that California, here we have majority of our drinking water source might be coming from surface water, which are located near the location which are vulnerable to fire. This is just the reservoir just to show that they're running full right now. Many of those, because of heavy rainfall, thankfully, we are out of, at least this year, we are not having the drought. But more likely, this fire quality, the water quality is important to us. We should not look or ignore the quality just because we have enough water right now. Next slide, please. And again, this is just to show that another examples of another lakes in California that has been now fire. Now you see that how the proximity is so close that it's important to understand how this fire affects the water quality in those lakes. Next slide. This is just to show that why we think that it's going to affect for a long time. As you see, every time there is a fire, it burns down the trees, it changes the soil physical properties. For instance, it makes them extremely water repellent. That means every time there is a rainfall, it's not going to percolate into ground. Most of them become runoff, and that will basically increase the flash flooding and energy associated with this runoff. So that means it's going to swipe a lot of these wildfire residues and stop and deposit them in the downstream. Many of them will deposit near the roadside because that's where we have these depressions where things will be deposited like sediments. So it's very important to understand the link with our ability to clean this water or keep these water sources clean. Next slide. This is just one few examples to show that how the quality may change. There are two streams over here. You can see the quality in one stream is very different from other based on where this is coming from. And on the right side, you can see that those effects would be severe, not just on us, but also many of these wildlife and other aspects. Next slide. So with that, I just want to highlight that this is this is an issue that we could potentially solve by our ability to design this green infrastructure to capture some of this pollutant released during wildfire or after wildfire. So Sanjay is going to take through the lab experiments he has done to show how it can be done, at least in the preliminary ways. So Onja, this is all yours.
Thank you. Hello, everyone. So I'm going to talk a little bit about the research that I've been working for 4 years now, which is about the impact of wildfire and water quality and how we can use green infrastructure to mitigate these impacts. Next slide, please. So wildfire can occur in urban spaces, and we know that the population in urban area are going to grow these following years, and there is an opportunity to use urban infrastructure to mitigate these impacts. And that's for the research I'm focusing on. Next slide, please. And the idea is to use green infrastructure. So what are green infrastructure? There are a stormwater treatment system. That means that they usually capture, store, and they infiltrate the runoff. So that's why it's good, because when you're in urban spaces, you don't have a lot of runoff. So when you walk, you don't water flooding. You don't have a flooding here. So they used to infiltrate the water, and then they don't just infiltrate the water, they also treat the water, the runoff. And once they treat them, they can be injected into groundwater, or they can be also used for surface water. Next slide, please. But we don't know if the stormwater treatment system, just green infrastructure, can be installed in wildfire areas. And we don't know if they're going to treat the post-fire runoff that Sanjay was explaining about, all these contaminants in this runoff. And as Professor Mohanty was saying, stormwater treatment systems are usually installed near the roadside. Next slide, please. But what happened is the runoff from wildfire area are going to wash all the contaminants, all the pollutants, and they're going to deposit that on the roadside biofilters. Next slide, please. And these green infrastructure, which are installed next to the road, can intercept the runoff. And of course, the more you have post-fire runoff and the more you have runoff, the more you're going to have an accumulation of wildfire residues. And how do we know if this green infrastructure can intercept these pollutants from runoff area? And that's all the research I'm focusing on. We want to know if we install green infrastructure, and despite having all this runoff with all these contaminants, if these green infrastructure can still be effective, and if they can really remove wildfire residues. Next slide, please. And that's the reason we are looking at two functions of the biofilter. So as I was saying, the first function of the biofilter, an example of green infrastructure, first of all, they are used to infiltrate the water. So we want to see if these wildfire residues from the runoff are going to affect the infiltration capacity of the biofilter. And the second aspect is the treatment. We use stormwater treatment system to treat the runoff so that we can use that for either like for other purposes, but also like to infiltrate that in the groundwater, to replenish the groundwater. And that's why we're focusing on these two functions. We want to see if the wildfire residues are going to impact the infiltration capacity of biofilters and the pollutant capacity of the biofilters. And for that, because as you may imagine, green infrastructure are very large scale, we model biofilter in the lab. Next slide, please. By using column. So we use column experiment as a way to model the stormwater biofilters, and we are focusing on what is happening below the soil. So that's why we say subsurface, and that's the name of our lab, subsurface. So we're looking at what is happening below the soil and how these wildfire residues are going to impact the functions and the performance of these biofilters. And for that, we to model this biofilter, we use sand, because sand is used to infiltrate anything, right? Even you're on the beach and you're walking and you can see the sand is infiltrate the seawater. And it's the same thing. So sand is used to infiltrate, to have this function of like infiltration. And then we also use compost. Compost, as you may know, it's everywhere in the and you use this compost to attract the contaminants. So it's an organic amendment that can be used to remove pollutants. So we have a combination of compost and sand. And in the model biofilter we have a drainage layer made of gravels. And then we add the mixture of sand, compost. And then on the top, we also add gravel, because if you infiltrate the water, the media may go up, and we don't want that. And then, because we're looking at the effect of wildfire residue on the biofilters, we did columns without wildfire residues, and then for the others, we accumulated wildfire residues on top, so that we are modeling, we're mimicking what is happening in reality. And you also use sand columns, which are usually used as infiltration. Next slide, please. And concerning the infiltration capacity, we noticed that, of course, the more you add post-fire runoff, the more the clogging will occur. But the thing is, if you scrap the biofilters on the top, so the layer of water residue you can see on the left. If you scrap it, and then you measure again if the infiltration capacity is working or not, you're going to notice that the infiltration capacity will be restored as it was before. And scrapping, I know it sounds a little bit trivial, but scrapping is a maintenance, a very common way to maintain green infrastructure in real life. So scrapping can help to restore the infiltration capacity, despite the fact that water residue runoff contain a lot of water residues. Next slide, please. And we're also looking at the treatment. Remember, I was saying that we are talking about the treatment of pollutants, including nutrients, pathogens, metals. All of these contaminants are in the runoff, post-fire runoff. That's why they negatively impact the water quality. And we noticed that having water residues on the biofilters does not affect or do not change the capacity of the biofilter to treat these pollutants. However, as you may notice, for example, in this example, for example, of phosphate, you may notice that compost and sand have already a very low capacity to remove phosphate, and I'll explain you later. But despite that, if you add water residue, it's not going to affect or negatively affect the removal capacity of the biofilter. Next slide, please. So from this experiment, what we learned is that biofilter can be resilient to post-fire runoff. That means that they can be functional if you scrap the top of the biofilters periodically, not always, but periodically, so that you have still two functions of the biofilter, which are infiltration and treatment of the runoff. Next slide, please. And now we are focusing on how we can better design this biofilter so that we can better remove contaminants. And that's how we are focusing now. Next slide, please. And an example is the phosphate graph I was showing you earlier. As you may notice, the capacity of biofilter to remove phosphate is very low with compost and sand. And the fact is that there is a lot of phosphate that can also cause algal bloom, for example, because of the fire suppressing chemicals. I'm talking about LA fire department, but any fire department they use the fire suppressing chemicals that have a high concentration of phosphate, but also from the burn soil, you also have a lot of high levels of phosphate. And indeed, compost and sand, which are conventional biofilters, which are called conventional biofilters, cannot remove phosphate. Next slide, please. But we have an idea. We have a great idea. We propose that if we use the sludge from water treatment residuals, maybe if we add this into green infrastructure, it can help to better remove phosphate. Why? Because in the water treatment plant, they use salt. They use iron or aluminum salt. In that case, it was in Long Beach. We collected that. They use iron and aluminum salts. They use that in a water treatment plant. And then they put that in the water which is dirty, not dirty, but at least the water which is not safe. They put that in the dirty water. And what happened is the salts are going to attract some pollutants, and together they're going to form a flux. So that's why we say flocculation. They're going to create we're going to say a heavy solids that are going to settle in the bottom of the water treatment residuals, or in the water treatment. And these usually are dumped in the landfills. And our idea is to use these sludge instead of having them on the landfills, but using them in our biofilters to see if they can indeed attract the phosphate. And that's why we went to Long Beach. We asked them if they can give us some sludge that they usually don't need, and we put that in our biofilter. Next slide, please. And what we noticed is that they can remove at least 97% of pathogen, E. coli, and phosphate, because water treatment residuals has a high concentration of iron, which is positively charged, and phosphate is, the iron phosphate is PO43 minus, so the minus attract the positive, and that's why, and same E. coli is also negative, so that's why they attract each other, and the biofilter basically attracts the pollutants, and that's why the effluent to obtain is clean. And if you have 20% of water treatment residuals in the biofilter, as you can see on the graphs, if you look at the 20% on the x-axis, and you have a removal of 97% for E. coli and for phosphate. Next slide, please. So yes, adding water treatment residuals can improve the ability of biofilter to treat the runoff from wildfire areas. Next slide, please. Which is a good news. And then I'm going to let Professor Mohanty talk about the future research that we're going to do in the lab.
Thanks, Sanjay. So here, what we saw, that very preliminary data that we can redesign the green infrastructures that's already been installed in many places in urban areas to improve or we prepare for this change in water quality. So next slide, please. What we're going to show in the next slide is that these are the current research that we are doing, which is basically to investigate how we can better protect the water quality that is used for drinking water treatment systems. For instance, in this illustrations that Onja drawn, what you can see here is in a normal case, if you have a lake that is a source water for many of the drinking water treatment plants, after fire, the quality of water is going to change. Basically, fire burned down the carbon, change the way this carbon, dissolved organic carbon behave. So now if you take this same drinking water treatment plant or drinking water for drinking water treatment plant, during disinfections, these organic carbons will interact and produce cancer-causing pollutants like disinfection byproduct. So that increases the burden on drinking water treatment plants to invest more and more to treat this water. But if you install green infrastructures, we could potentially limit that cost in upstream. Green infrastructure has many benefits. So by adding that, this is just one more benefits for drinking water treatment plants. So this is just one example we are looking at. Onja is doing that research right now, and we have very good results. So obviously, next time, hopefully next year, we'll share those again. Next slide. Then there is another research questions. We are more like an ecosystem level that we are examining, is what happens to those the coastal marsh or wetland that we have it to protect the ocean ecosystems. So these coastal marsh or wetlands are going to be affected by many of these runoffs. For instance, we have a lot of flooding this year, and that might have suspended or washed up many of these wildfire residues to those areas, and so those that's going to change the geochemical processes or the microbial community that break down nutrients or release carbons or break down carbon and does a lot of different functions. So we are looking at those effects so that we know that these wetlands are on at least functions how it should be, and if not, then what different kind of actions, remedial action we may take so that we can protect them. Next slide. So these are just few of the examples just to show the link between wildfire and water quantity or quality. What we need is first thing is we really don't understand this effect because rarely we do monitor these systems for long enough to see this impact. So we really need a coordinated monitoring effort between state agencies, local agencies, academia and industry, so that we create this database showing how the quality is changing over years. And second, we also need this, understanding this science, linking these long-term water quality effects to wildfire, particularly for the reservoir water quality. And we also need to improve the model because we don't have much monitoring data. We really can't validate any models right now. That's why it's important to develop both that links all these complex processes together. And in the infrastructure scale, we could think of green infrastructures not just what they do, they also are a solution or could be a solution for wildfire negative effect of wildfire. We all knew that green infrastructures in urban areas can have multiple functions, reducing the negative impact of climate change. We also now know that it could have also positive effect in protecting water resource from wildfire area. So that means we need to invest on this. In particular in Los Angeles, we have a Measure W, that $300 million a year. That's kind of development. We could really make a difference in at least in these areas. Next slide. These are just citations just to show that if you are interested, we can send you any of these articles. With that, I will now forward to Greg, to have other talk about the broader issue on wildfire.
Yeah, thanks so much, Sanjay and Onja, for that presentation and bringing up a number of, sharing your research and bring up a number of questions that I know folks are eager to get to in the Q&A. Before we do that, though, I want to turn the floor over to Ken Susilo from Geosyntec Consultants to make some remarks and reflect based on his vast experience in both the private and interacting with the public sector on your research in this broader topic. Ken is the Senior Principal Water Resources Engineer at Geosyntec, or is a Senior Principal Water Resources Engineer at Geosyntec Consultants. His work specializes in development, including alternative delivery of multi-benefit, environmentally enhancing solutions to stormwater management. And a major part of his work involves finding solutions for permitting issues relating to the Clean Water Act, and particularly NPDES permits, if you all are familiar with some of these acronyms, but across a broader range of really local water supply, environmental issues with local water agencies. And with that, I'll turn the floor over to Ken.
Thanks, Greg. Thank you for that presentation. It's exciting work you all are doing, and sort of thinking about the whole continuum of the needs and the importance of addressing wildfire, and particularly impacts to waters and water supplies, receiving water quality, beneficial uses of receiving waters, and the whole suite of kind of the water space. It's really important that we do dig into and start solving some of these problems piece by piece. I appreciated the analysis on metals, because metals are a driver for impairments, as well as nutrients and pathogens. I think you've been doing a lot of research. We have a fecal indicator bacteria that are kind of indicators for some human health risks, but ultimately we also are going to be looking at pathogens as a real cause for potential human risk. So these are all kind of important elements, and it's important to understand what impacts wildfires have, particularly at that interface with the urban and the suburban environment. So, that's really helpful. I think as you all go through your research, I'm going to give you some perspectives from the applied side, from the practitioner side, because Geosyntec, as a company, we do a lot of post-fire erosion control work. So like getting out there immediately after the fires are complete and do some slope stabilization and erosion control work in order to kind of stabilize the sediments, because I'm guessing, and this is something that it would probably make sense to tease out a little bit more when you're talking about things like metals or bacteria, that whether there's a sediment, how much of this is particulate, how much of this is dissolved. And I think that'll also help inform the analysis of performance in terms of the green infrastructure and the biofilters. We also do a lot of two-dimensional debris flow modeling. So the way that mud flows behave is a little bit different than clear water flows, and that directly impacts the green infrastructure if you get into the sphere of influence of heavy sediment and debris flows, because that can severely impact your green infrastructure performance. Green infrastructure is also a big part of what Geosyntec does, and the whole treatment processes. I think it's a really important analysis that you're doing, looking at biofilters. And one of the things that is helpful to us as engineers and designers are to pull out some engineering parameters like hydraulic conductivity, porosity, and hydraulic residence time. As you're looking at pollutant removal capabilities, understanding those metrics helps us in the practitioner side design BMPs more effectively, because we see sometimes if you're looking at particulate matter versus dissolve, if you're looking at bacteria versus nutrients, some of the criteria might change a little bit. And so having that understanding, hopefully it's not new information, but it's kind of keeping track of some of those things, because there is such a dearth of information out there. But as you're collecting, kind of keeping those together is something that's really going to be helpful to us as practitioners who are charged with designing and implementing green infrastructure. A couple other things that are really important that I think that you all are touching on. One is as you are going through data collection, there's a temporal scale there, and then there's a revegetation that can happen, because ideally, as you have a wildfire, you are doing post-fire erosion control, and there's a reestablishment period. And so taking a look at how that impacts your water quality is going to be an important element. Another side thing to make observations on are native versus non-native plants and seeds that kind of get transmitted and washed down to the watersheds. As Greg mentioned, we do a lot of work in terms of the regulatory space. So MS4 compliance, municipal separate storm sewers, sort of the city urban infrastructure. And in the context, a lot of the drivers for that Clean Water Act compliance is the restoration of beneficial uses of the receiving waters. And so in some cases, if you have fire impacted watersheds and heavy sediment loads and those types of things, not only if you're a water supply reservoir, it's clearly an impact. If you're receiving water within a municipal storm drain system or within rivers and creeks in an urban environment, that they can be pretty significantly impacted. So there's some, it makes sense to take a look at, for the regulators to take a look at it and sort of account for the fact of what's going on with respect to fire impacted watersheds. The good news is that a lot of those regulatory requirements do examine natural background loading. That's how they look at bacteria. That's how they look at some, other pollutants of concern. So it's something that can just get integrated. But as you look at the WTRs in terms of the design of green infrastructure, another thing that we'll need to take a look at is if you're putting something in the waterway. And so there's a permitting kind of cycle and a clearance that you'd probably want to, work through with the regulatory community and make sure that that stuff, is acceptable in terms of introducing it into the stormwater stream, if you will. So that we're not introducing anything that's potentially going to cause a regulatory impact or some sort of impairment to beneficial use. So there's lots of great things that we could go on and about other types of things. This is really exciting work you all are doing, but maybe I'll leave it at that. And then if you want to talk about any of those elements, that's fine. Or Greg, if we're going to open up to questions, I'll leave it to you.
Yeah, I think we'll open it up to panel discussion and questions. And for that, I think you can brought up a number of interesting and pressing issues to build on this work. I'm going to turn the floor over now, last but not least, to Hayat Rasul, who is a coordinator of the UCLA Water Resources Student Group. She's completing her master's in urban planning at UCLA and has a lot of experience also actually working on the Safe Clean Water program. So she's going to help facilitate both for sort of a panel discussion and then the open Q&A, including, again, many of the questions you all have raised in the Q&A function. So Hayat.
Yeah, thank you so much, Greg, and thank you for sharing, Ken. And of course, thank you to Faith, Sanjay, and Onja too. We're grateful to have your perspective and experience here today. So again, my name is Hayat. I study water and who and what water interacts with at the UCLA Luskin Center. But I've been keeping track of your questions in the question and answer function at the bottom of your screen. Again, I see a few hands raised. Please use the button at the bottom of the screen so we can get through your questions in an organized manner. But we're going to spend about 20-ish minutes answering your questions. So let's get into it. And let's see, first question. This might be geared more towards Faith, but of course, other speakers today, please chime in as you have thoughts. The first question is, what are some best practices for communicating the Wildfire-Stormwater Nexus to diverse audiences or constituents with an emphasis on environmental justice communities? Do you want me to repeat that? Let me know.
I'm happy to sort of kick things off, although I think that there are folks could probably weigh in as well. So as Greg mentioned, I had a book come out called Getting to the Heart of Science Communication that really puts forward a sort of community engaged science communication model. And so that's mostly what I'm a big advocate for, is sort of local, place-based, very community engaged science communication, finding ways that communities themselves are asking questions and trying to be responsive to those. Although I will say that with these kinds of issues, the water and wildfire, very emergent issues, I think there can also be this challenge to communicate things that people may not be worried about yet. I think that there are components of this that people are worried about, but I don't even think we've seen enough of the entire issue to even I don't know what to be fully concerned about as a resident of the state at this point. So I think on these kinds of issues, we need to find some creative ways to talk about things that people aren't worried about yet.
Yeah, thank you for that. Communication is key, right, to connecting folks with varied lived experiences too. So yeah, if anyone else has any thoughts on that.
I mean, I just want to chime in that we engineers are always been notorious for good communication. So it's something that we looked up to other scientists and other help from communications and other departments to effectively translate the science into something that other can understand. So I really, this type of webinar is definitely one way for us. So I'm very thankful for Greg and others to really organizing and making that effort.
Yeah.
I guess I have an indirect kind of response to the question, I think, as well. I think something that's important in terms of communication is around the need for water quality treatment, but also the cost that that's going to really mean for public agencies and other types of utilities, and just to be, I guess, to communicate that to the general public, but then also find ways to communicate to decision makers that we need to shield, folks who can't pay for at least rapidly increasing water quality costs, find ways to shield and make water affordable despite these challenges and these higher costs we're seeing. And they aren't just, of course, related to wildfire, they're related to a lot of other pressures, first and foremost, climate. But yeah, I think that's a kind of an answer to the question, perhaps.
And
Yeah.
just to add on the cost, something I want to add, that many locations we are already we allocated money to install green infrastructures, but many times people don't even know that this can be useful for something like wildfire. So a lot of times, that cost could be, this is something already, we can include that, saying that this is something that is useful for many other things that people may not have thought of. So that's, yes, this is again, communicating the benefits and all that cost is very important, so that we have the resource to develop the things that's needed.
Right. Yeah. Thank you for sharing that. And I think that's a great segue into a question that is summed up by some of the questions you answered via the question and answer function. But in regards to operation and maintenance. So I think you and Onja and also Ken can speak a bit to that. How can we do operation and maintenance on biofilters at a large scale?
I think, I could add, Ken definitely would have much more understanding of operational maintenance cost. We, work in lab, we don't really, do that directly. So I make sounds off a little bit, but what I understood from now that maintenance and operations, that's almost like 50%, sometimes even 100% of the design cost. And that also, we don't do that beyond second year of installing these green infrastructures. So now what we saw over here is that if there is a wildfire in that areas, that maintenance is not going to occur for many years despite all these fires. So we got to have, again, the come back to the cost, and last, having that money is important more than the, how often what we can do, because that drive the challenges, not the, how frequently we could do or we can. Ken might be, able to add on top of that.
Yeah, maybe I can elaborate a little bit. Even under ideal situations, so non-wildfire conditions, the maintenance of green infrastructure like biofilters is an ongoing challenge, right? If a BMP or a best management practice or green infrastructure is not well maintained, not only can the functionality kind of be eliminated, but it could actually create a nuisance or a potential risk to the communities due to clogging and then a lack of capacity from a hydraulics perspective. So if your biofilter's clogging, it's an inline system and you don't get water into the storm drain systems, you actually have, create some risk there. So that's under the best conditions. When you have a wildfire impacted watershed, now you're looking at potential heavy sediment loads and potential overwhelming of these systems. So it could overwhelm the vegetation in the systems, it could clog it and cause a complete, if it's a minor thing, it could be the scraping that was discussed. But if it's a kind of a heavy sediment load or a debris flow, it could cause a rebuild potentially. And that's why in some cases, having things like sediment basins or pre-treatment kind of facilities to allow for sedimentation and a heavy loading of particulate, so that you don't have to tear up your biofilter and remove it is an important element. So that can be incorporated into the design portion. But then I'd also say post-wildfire, and there's an analog here with green infrastructure, in a heavily urban environment, which is in an urban green infrastructure, you get trash loading that clogs up your biofilters and then it doesn't work. In a wildfire impacted area, you could have significant erosion from burned hillsides. So that's where the erosion control and vegetation reestablishment can be an important component. It's really sort of in the source control category of things to keep sediment from coming down so that your biofilter doesn't get clogged and damaged. So a couple ways to look at it, but you have to kind of take a look at the whole thing and see where your vulnerability is and then try to mitigate that either by immediate action post fire or something in design when you're sort of doing your planning. At least that's my my experience in this space.
I'm learning so much. Thank you. Yeah, and someone else asked a question about scraping. So please, if you asked that question and it was answered, I think by Sanjay, if you want to elaborate, you can feel free to type that back into the Q&A function. But let's get to some more questions. Michael Mendez, thanks for joining, Michael. Says, great event and research, thank you. Over the years, has the state board and regional board adopted policies, regulations to address these wildfire-water nexus? This wildfire-water nexus. Have you shared your research with policymakers?
I have a short answer. No, we have not done it. This is our first chance of doing so. So I think, that's something Madeline and other could really, connect, because that's where they, they did the best.
Awesome. Well, we'll have some follow-up from Madeline then.
I also, I'm curious if Ken has any answer to that, but I'd also say, I'm aware certainly of the state board getting involved a little bit on sort of wildfire water supply impacts when they impact water system infrastructure or even emergency water, but I haven't heard of it in the context of stormwater green infrastructure impacts directly. But I do think it's an important question, as it always relates sort of back to financing and O&M questions, how the state and how regional boards think about these issues or whether they think about them in this specific realm. I don't know, Ken, if you have anything to add, no pressure.
Oh, I would say a lot of my experience in this sort of post-wildfire space is a lot of things are in an emergency phase, right? So we're understanding these are extreme, almost force of nature kind of events, right? And so a lot of the actions are emergency response. So we see stabilization of slopes, and we see, other things in order to not impact. For example, we saw a situation where you had mud flows post-fire impacting a sanitary sewer system, causing sewer lines to break. So that was just get in there and fix it as fast as possible. There is some regulatory allowance for natural conditions, so background conditions. For example, the bacteria example is that natural watersheds exceed bacteria criteria if you're looking at fecal indicator bacteria with some regularity. So the intent is not to make it any worse than a natural condition would be. So the argument would need to be, what exactly is a post-wildfire situation? Is that something that we know historically in California there has been a history of fires. There is obviously with climate change, there's increased temperatures and the potential for increased wildfires. Is whose responsibility is that to mitigate, or do we get into a response and mitigation kind of framework? So it's a big question. I don't have an answer for you, Greg, other than some observations.
Well, thank you for answering to your best ability. And I have a follow-up question to that, and then I'll get to Drew's question. You mentioned, California having a history of wildfires, and everyone knows what an atmospheric river is now with the past few months of heavy rains. How can we get ahead of emerging fire water quality dynamics to ensure better water quality and supply, or do we need to be reactive? So do we need to get ahead of these things, or do we need to be reactive? What do you think is the direction we're going in right now?
Sorry, can you repeat the question? I just got a little distracted in answering
Yeah,
the question.
no problem. I know it's been a long day, huh?
No, sorry.
So I was asking if or how we can get ahead of the stormwater wildfire nexus in terms of dynamics that we can foresee happening, or should we be more reactive to the things that we understand about it now?
I think any kind of wildfire research has been reactive for ages. We do research, even monitoring a part is mostly reactive. Wildfire happens, we take samples. There is no way to know what happened before wildfire, so there is no control. That's something Onja pointed out. If we don't understand the extent of issue, we can't really have a solutions that we can't really compare whether our solution is actually improving anything or not. So yes, coming from reactive to proactive would be much better. First thing is not just water quality, how to prevent wildfire in long terms. For instance, water availability is one of the big part of wildfire frequency. So having water availability issues also tie with the wildfire research. So we are doing a lot of work on that water availability, all that aspect. So we can follow the similar approach for wildfire. Well management, as well as how that's one thing. To prevention is better than cure. That's the first thing to do. And then second is for many of these green infrastructure is just one small part of the solutions, but we can't just look at just one aspect of it. It's land management, it's water management, it's a holistic level. So I think proactively having more discussion at the state level would help create the guidance documents that will eventually inform all the stakeholders as well as industry, academia to collectively do more research on it to have better solutions. So yes, I would always go for proactive as opposed to reactive.
Right. Well, thank you. Anyone else have any thoughts?
Yeah, maybe I'll build on that a little bit, because I agree the proactive approach in an ideal world with adequate funding to do everything that's important that we can anticipate and knows what's going to happen would be a great thing to do. Obviously, there's some elements of trying to get the resources to promote those proactive activities on land management, those types of things can be a challenge. From a technical standpoint, though, I would say, in terms of what academia can do, there are tools that could benefit from further development in terms of predicting, anticipating, and maybe helping with the planning side of things. So it doesn't mean we have to sit on the sidelines and pretend like we don't know what's going to happen. We understand that there's going to be fires, there's going to have burn intensities, we're going to have remote sensing, we're going to have different ways to try to characterize what those fires are going to be. We'll have the ability to look at what vegetative cover and how that cover is going to change over time. So tools can be developed in terms of taking a look at it and figuring out, what do we have at our disposal, and what can we do some research on, so that we can be better prepared to optimize the resources, so that when we do get into the reactive space, we're able to really commandeer our resources more cost effectively.
Right. Yeah, that makes a lot of sense. Thank you. I'm trying to get to a few more questions before we close out, but Drew asks, well, first, Drew thanks Sanjay and Onja for their research, and is asking specifically about native plant species and the role that they can play in removing pollutants like nutrients, heavy metals. So Drew says that they've seen this research in other regions, but so far not California. Is there any concern about pollutants in sewage sludge added to the green infrastructure, contributing its own pollutant contamination to our waterways, wetlands, etc.?
I guess I could. There are two questions here. First is the easiest one I'll answer is the why and why not we don't have research on whether or not the native plants could capture some of the pollutants. I think the first thing is it's very hard to maintain plants in California, at least in Southern California. So there are many places that are looking for how we can maintain these plants and not to have to irrigate them. So that's why probably one of the reasons we have not seen it on much research. And second, we do believe that plants has a better role, important role to play in green infrastructures. That's why there are many systems where plants are there. In academic standpoint, I know that some studies has been done in UC Riverside about it, but plants' ability to capture pollutant is a slow process. Anytime this kind of storm event happen, it's a very rapid process. So the bulk of the pollutants left in the systems are done very quickly. So that's why the capacity to remove the pollutant would be much more influenced by the media, the interpretations and all that aspect. Having said that, yes, it's an important part. People should use the native plants to phytoremediate some of the pollutants. And the second question was the risk associated with the sludge. So this is not a waste sludge. It's just to ensure that this is a drinking water sludge, which is a pretty much more cleaner than wastewater treatment sludge. And so it has mostly enriched with irons, aluminum, sometimes some of the other pollutants that may be in the source water and drinking water treatment system. We believe that the iron itself, when they precipitate, they bind those metals or other pollutants strongly, so they don't release. And Onja has done experiments, just to potentially see what comes out of the drinking water treatment residuals itself. And so Onja, can clarify. She has a data that shows that not much, at least not the level where it's a concern. But it could be, depends on the location to location. So it's important to screen those water treatment residual before you add them in drinking water treatment system or in the green infrastructures.
Great, thank you. Madeline, I'm seeing your note. You have a question if you would like to share now. You're still around?
Can you hear me? Thank you.
Yes, we can.
So I wanted to say what a great job you've all done, and certainly willing to help you on doing anything future in terms of talking to groups. But the one question I have is, our fires are huge, covering millions of acres, hundreds and hundreds of stream tributaries to major rivers. How feasible is it to think about doing distributed treatment systems that will affect the water quality in these rivers and tributaries. I think the question is for you, Sanjay or Onja.
Yeah, Madeline, sorry, I was reading one of the questions and the time again, I got distracted by reading. There are great questions. So I'm sorry, I didn't really know.
Okay, well, I'm going to repeat this, is that
Yes.
the fires are over millions of acres, over hundreds and hundreds of streams and tributaries into rivers. And I'm wondering, I'm trying to visualize a system of these kinds of biofilters that would be added to green infrastructure, and how many there would need to be to
Yes.
have an effect, and whether or not it's feasible to think of it. I mean, I think that you proved a great point that it works, but can we afford to do it?
I think that's a great question. This is a question of scale. If we imagine there is a big mountain, it got caught fire, and then next time it rains, where the water goes, we just have to think of whether that much water can be treated by biofilter. The answer is no. We can't treat that much water in any green infrastructure. That's why what Ken mentioned is an erosion practice, like having a detention basin. Different kind of green infrastructure is much more helpful. So having those detention basins, natural wetland, natural marshland, these are more effective way of remediating the effect. In fact, that's how nature does all the time. What I suggested here, green infrastructure, is more about looking for the long-term damage. After the fire, you have little rainfall happens, and these pollutant release for years and years. And in this case, these diffuse source pollutant can be mitigated. But for a large-scale process, it's much better to have something like large-scale system like wetlands or natural systems or detention pond.
Thank you.
Great.
I might just add that it also helps on the O&M side when you have any kind of regional, sedimentation basins or those types of facilities, because it is quite a lift to try to do extensive operations and maintenance on a distributed system. But if you can centralize some of that, it does help.
Any other thoughts? All right, well, shifting gears a little bit, I think we have time for maybe 2 more questions. Going back to, the basis of your work and also your work that you do at Geosyntech, Ken, are there historic data records, Kelly asks, regarding past wildfires and the contamination of surface waters that you actively use in your work?
We don't actively, I'm trying to think about an example where we've used that, and I can't think of one right now where we've actually used that. I know that there's ongoing studies being done on wildfire water quality impacts and how you might account for it. But I do think there's a temporal issue in terms of revegetation of slopes. And when you have the storms, and then there's an intensity component too, particularly when you think that if you assume that most of it is going to be sediment related, then actually how you analyze your pollutant loading and your concentrations is going to be important, because some of the urban pollutants that have sort of a buildup of pollutants and then a first flush, and then it kind of goes in, and you have a different pollution profile than you would if you're looking at something that's sort of erosion based. So those are all sort of considerations, but I'm trying to think about I don't know off the top of my head.
Yeah, I mean, there's such a vast range of data sets you could look at, right?
Is.
Sediment cores, water quality right after a pollution event. There's just so many things that you can look at. So I don't know if you have thoughts, Sanjay or Onja.
I think historic data, Onja, you can answer these questions, because she has scrubbed through all these data sets and everywhere to find out any wildfire related data. So answer is no. In my view, there are many data, but Onja, do you know anything recent? where you have seen historic data being used for past
for historical data. I think the most recent I seen was, I think 1 year ago, from Emerton. He shared some historical data about the impact of wildfire on water quality. But I haven't seen that much, to be honest. And I haven't seen that much historical data about wildfire and water quality. Yeah. Sorry, I'm trying to think at the same time about all the studies that I'm trying to read all the time. I think usually when you read about a study of water impact of water and water quality, they look up maybe like 10 years ago, and then look at the impacts of what happened 10 years ago or like 15 years ago. Colorado, for example, has a lot of study about the impact of wildfires on water quality, because this is a huge issue in Colorado too. But for historical data, no, I don't have, sorry, in my mind so far, I don't have a study that can about that. So yeah, maybe more research is needed for about that.
That's what I was going to say. That's what we got. More research is needed.
Right. I am going to ask a question that is at the end of our Q&A list here by Jasmine, kind of switching gears to policy. So to just diversify our question set here, but Jasmine asks or says most of the fires are happening in state-owned parks, federal government lands, and I'll add tribal lands in the state of California. And I do wonder if it's feasible to have state or federal government be involved to create the infrastructure to protect our communities. So what are some funding avenues happening right now, or policy avenues happening right now that can perpetuate the infrastructure that is needed?
I mean, I can say that not many policies right now, because again, that lead to, we don't know even the extent of the problems, because we don't monitor. Because we don't monitor, we think there is no problem. It's like, I can't see it, because if I can't see it, does not exist. So policies are usually driven by data, and the data has to be there for, to inform that policy. At least in my knowledge, I have not seen any policy that directly link with this infrastructure development with wildfire. So again, something is very early stage. California could definitely take that leading roles. I have seen some of those policies in Australia. I have read about them, but not in California.
I think, I'm interested to hear if Faith might have anything to add, but I do think we haven't done a lot historically. It's a great point about where, a lot of the acreage for wildfires is occurring. And there is more being done quite recently on sort of forest management and upstream water quality impacts and reaction in many ways to the historic wildfires we've had over the last decade in particular. But I'm not sure some of the particular approaches we focused on here make so much sense in those contexts as much as closer to the urban or in the urban context. But I know there's some pretty innovative partnerships that are happening, at least piecemeal, on the sort of upstream restoration or preservation front, and kind of in fuels and, again, forest management more broadly that impact water supply. I don't know the names of particular funding programs, but if someone wants to follow up with me, or Faith perhaps, I think we have some of those highlighted in our report. They just don't come to the tip of my tongue right now. Faith?
Yeah, thanks, Greg. I would say similar. I've seen these sort of more piecemeal approaches to things, and what I have seen on the green infrastructure side has really been at the local community level more than thinking about state or federal lands. So it's a really good question. I mean, I think again, in that report that Greg's referencing, we really tried to break things up a little bit into these sort of forested watershed, very upstream, almost like, pretty much Sierra watersheds and what's happening at that scale, where I do think you're seeing more investment. And I think on a grand scale, I would say, that there's a group out of Santa Barbara whose name I can't remember right now, who's really looking at these sort of green infrastructure within the context of a city that is doing some really interesting work. But yeah, I think it's just really, really piecemeal. All of these issues are really piecemeal right now. And so I'm super interested, like, even in the comments, Maxwell is mentioning the California Department of Insurance is interested in some of these issues. I had never heard such a thing. So I'd be super interested to kind of hear. And I think this issue is just getting to the point where we can start to talk about it on a large scale. Not super satisfying, but I think the state.
There may be an analog here, and it isn't quite as directly related to who owns the forests and who owns the land. But when you think about flooding, for example, there's an annual exceedance frequency. There's a risk analysis that's done where the federal government comes in and does, provides flood insurance and flood mitigation. That's where I think where Max was talking about in terms of where the insurance world is coming in. When you have all this information, you have the data, and you're able to characterize the risk, and there's some sort of anticipated frequency and some sort of damages. The dams folks look at risk-informed decision-making in terms of how they make decisions, and there could be something from an agency like FEMA or the Corps of Engineers that really looks at infrastructure that's designed to mitigate an environmental impact that has some sort of measurable or statistically calculable frequency. And then you can do an economic analysis to establish, whether or not it makes sense in those areas, which is a different way to kind of address the question, but it might be another pathway to look at where policy and funding could translate into mitigation or pre-mitigation.
Well, great. Thank you, everyone. I see that some of our panelists are actively answering questions in the Q&A function. So thank you for being so proactive to get to everyone's questions. I really, really appreciate it. I know when I am a participant and my question's not asked, I get a little anxious. So thanks for doing that. And I guess I'll open it up for any final thoughts from our panelists, and then we can pass it off to Greg to close out.
I just want to say that Onja has been working on wildfire. I know that certainly there are other researchers have been working on wildfire. This is having a more like a workshop or this kind of events, inviting those labs would be much more helpful, because just one side of story. There are a lot of other things. So this is a great initiative. I'm very thankful for Greg to take that initiative and make it happen, because I definitely would not have get it done on this scale before.
Thank you so much, the UCLA Water, for giving me this opportunity to share our research. It's very important. There is so many questions, and that's good because we don't have the opportunity to talk about that very often, to be honest. And like the question, which is not answered yet, but I know Sanjay is writing it. It's a very good question. Last summer, we bought the firefighting chemical that LA Fire Department used to try to analyze how this phosphate can negatively impact the surface water. We have ongoing experiments to see how this fire retardant can contain PFAS, phosphate, high concentration of these contaminants, and indeed they can impact the surface water after rain. So the concern is real, to be honest, and this is an experiment which is ongoing. And please feel free to reach out to us because we are happy to share the results as soon as we do the experiments. But yes, indeed, the firefighting chemicals are a concern, and that the top researchers have been focusing on that. I know Stanford is trying to find another firefighting chemical because of the issue which is discussed by the analyst attendee. But yeah, thank you again. Thank you, everyone, for all these questions. and for your interest.
Yeah, and I think I'm gonna close it out here. And again, thank everyone for attending. Thanks for all the great questions and discussion. Of course, I want to thank all of our panelists, and you can see their Twitter tags on the screen in front of you. Sanjay and Onja for the great presentation, and Faith and Ken for sort of the introductory and responsive remarks, the presentation, and of course, Hayat for artfully handling the Q&A with so many questions coming in. I also do want to thank McKenna for organizing the back end of this webinar. And again, thank all of our partners who sponsored the webinar, the UCLA Luskin Center for Innovation, Samuel L. School of Engineering, Geosyntec Consultants, and University of California Agricultural and Natural Resources Extension. But most of all, again, I want to thank all of you for joining and encourage you to get in touch with all of us if you want to follow up and to follow and engage with the work of the UCLA Water Resources Group and really the broader community on these pressing and timely issues. They're not going to go away in the next few decades, but we're trying to do as much work as we can to get ahead and respond to problems, and we know you are too. So we want to be in community on that front. Thanks for joining, and have a good evening. Thanks
Thanks
everyone.
all. Take
Thank you,
care.
everyone.